Hi everyone, can you all able to hear me?
Yeah.
Guys?
Yes.
Okay, thank you for confirmation. Okay, so in the last week and all, we were discussing about deep learning concepts. Okay, and we discussed about ANN, that is artificial neural network. What is deep learning? How it is different from machine learning, and what is ANN and their architecture. So from today onwards, guys, we will be starting with the further topic of artificial neural network. So the agenda would be, and then we will be doing some projects also. Agenda discuss about first activation function, then we have loss functions. We'll discuss some of the commonly used loss function. Okay, and then we'll talk about upcoming topic, let's say convolutional neural network. These will be upcoming topics that we'll discuss, okay, in this week. Now the very first thing we'll discuss what exactly activation function is. Now guys, what exactly activation function? You have seen one thing, there is a certain threshold is required for a neuron is fired. Okay, what is the characteristics of a neuron? Neuron can be fired or cannot be fired. So inside a neural network, we can create multiple neurons. Okay, let's say you have created 500 neurons. So the output of neuron is considered or not depends upon the threshold. If a neuron is able to achieve a threshold value, then we say neuron is fired. And if neuron couldn't able to achieve a certain threshold, then neuron is not fired. So whether neuron will activate or not, who will decide what kind of activation function we are going to use? So there are multiple activation functions. We have sigmoid, ReLU, leaky ReLU, TANH, etc., etc. We will try to understand their theory concepts, okay, and we'll discuss their maths part. Here, Sam, you're trying to say something.
Good evening. Yes, I have things to say. I'm sorry, I will look like I'm dragging the class back. I would have expected that there is a transition. We are new here. We're brought here at a time and we did reacted that we don't know why we're here. And the class has started without a transition from what we know to what you have taught to see if there is a congruence on what has been taught to us. And then we can then understand where you stop and see where you are going and be able to transit with you.
Okay, no problem. See,
Yes.
actually,
So
I had a word with your trainer also. So whatever topic we have covered, the same topic has been covered by your trainer also. I think in the last week, deep learning was started in your batch, and you covered the artificial neural network, right?
yes.
Yes, that's correct.
So yes, in our batch also we have only completed artificial neural network. So we are starting a common topic for you also. So you are not ahead or behind any of the topic. It is in the sync.
I
Okay.
understand that, but it would have been interesting for you to review what you discussed last week, so we know, we understand what you said, and then we can go along with that. Different lecturers or teachers have different approach to explaining certain things. So the understanding you have given to your team of students will be different from what we will explain. because they are two
So
different
in the
features.
in the artificial neural network, what topic you learn in the hands-on? It was on MNIST dataset, right? MNIST,
Yes.
yes. So same dataset we have used also. I have seen the hands-on and seen the everything. It is exactly same. Nothing is changed. Okay. The same hands-on you also have practiced. That is why I'm very confident that both the things are actually going in the sync. And whatever topic we are going to learn, it is also linked with the previous topics. Okay. So when I explain that, it will be also covered and you will able to review what I explained in the last week also. Okay.
And there is a second question that this is very personal to me. I have asked the question and nobody have answered that question, that why am I in a night class? I don't like doing anything on Sunday nights because that is when I prepare for my week. So this class is going to go into Monday night and I don't like it. So I don't know why I have been brought into a night session. I deliberately choose 9:30 to 11:30 a.m. session for me. So I still do not understand why this class is merged and the night session was not brought to the day session. Rather, we are the one brought to the night session. Somebody needs to explain that to me. It's not the
Okay,
reason
no
I didn't
worries.
choose to do.
I'll just inform the team that you have some issues with the timing. So
I
you get a
have
call
said
back.
it. I did not get an explanation. That's what I'm saying. I didn't.
I
All that I
cannot
was told is that there is a
okay.
project.
Yes,
I'm
some
saying this
projects are going
because,
to yes, some
yeah,
projects are also going to start. Okay. You will be learning
yes,
about
but
the
that
project
was
for
never what I'm saying is that you see, I'm saying this because you are recording this so that whoever is listening should listen. We were told there will be project in this training, but we're not told we're going to be doing night shift in middle of the training. When I discussed at the point of starting this program, it was a day training session I chose. And this session was existing. I never chose it. And I work. I work Monday to Friday. It's very unfair for a class to hold in the night. If I'm comfortable with it, I would have made that choice. But all the explanation given to me is that there's a project. I know there's a project involved in this program, but it wasn't for me to do it in the night. My night is meant for something else. I have to sit down at 8:30 till 10:30 when I should be in bed. I raised this the last time, and again, you see, they don't just throw something. There is nothing wrong with pushing this class to 7 p.m. for me and say 7 p.m. to 9 p.m. I can still manage that, but why is 8:30 to 10:30? So whose convenience is it? Who is choosing this specific time? That's the question I have to ask. If you are managing two classes, they should respect those of us who are coming from the day and push this thing midway and not just push out into somebody else's class session.
Okay, no issues. So you get a call. I informed the team already.
I'm not
Okay.
calling anybody. I've made my point. You can continue the class.
I
I'm going to
cannot
be
answer your
angry all
questions.
through.
Yes. I cannot answer your questions because I don't have any information regarding like you have time issues. Okay. It was like the projects are going to start a common projects for your batch and this batch. So it was must, okay, for the project sessions. And if you have the issue with the timing, no worries. You can drop the meeting, okay, and you will be continuing with the evening batch, whatever suitable timing you have. But yes, uh, for that I texted also to the team. You can explain the same to them, and then you get your accordingly batch where you are comfortable. Okay. Fine, Sam. I have no answer. Like you have timing issues or something. So again, uh, definitely you should go for the timing where you are comfortable. Very genuine. Okay, shall we continue, guys? Others, any question? Anyone want to say something?
Sir,
Fine.
when we
Okay,
will
so I'm
get
just
feedback, sir, Preeti here. When we will get feedback about our assignment that project we did?
actually I did not receive all the projects. So once we will get all the projects, okay, then we will be evaluating that.
Okay, sounds good. Thank you.
So guys, let's discuss the topic activation function. Having said that, you have multiple neurons in a neural network. So which neuron will activate, which neuron will not activate? It depends upon the threshold value and what kind of activation function we're gonna use. That function is responsible for activating the neuron. So I can define here in simple terms. An activation function in deep learning, an activation function in deep learning is like a switch or a gate that controls, okay, the flow of information through each neuron in a neural network. So in simple word, an activation function in deep learning is like a switch or a gate, okay, that controls the flow of information through each neuron in a neural network. Or in simple word, you can write here, the activation function determines the criteria for firing. Determines the criteria for firing. So whether a neuron will fire or not, it depends upon what kind of activation function you are using. Okay. So let's discuss the theory, maths, and practical implementation of this activation function. So now topic is types of activation function. The first activation function is sigmoid function. I think you already heard about this function in the logistic regression machine learning algorithm. Remember this function, guys? Sigmoid function in the logistic regression. Bharat, remember this function in the machine learning part, Vivek? Preeti, is my voice coming up?
Yeah, its voice is coming. Yeah, I
Okay.
remember this sigmoid function. Yeah.
Yes, well.
Okay. So what this actually function does, you have a equation for that, I think. Remember the equation? Y equals to 1 upon,
1
or you
upon
can
1.
just write Z equals to, you can just write sigmoid Z 1 upon
1
1
plus.
plus e to the power minus y.
Right.
This is the equation of sigmoid function. And if you wanted to check the range, okay. So guys, the range of sigmoid function is from 0 to 1. If the Z value is greater than or equal to 0.5, okay, the neuron will fired. Okay, then only the output of the neuron will be considered. And if Z value is what? Less than 0.5, neuron will be not fired. And if I show you the graph of sigmoid function, this is plus infinite, this is minus infinite, this is also plus infinite, and this is minus infinite. So see, this is 0.5. If any value is crossing the 0.5, these points, they will be considered as fired. Otherwise, they will consider as what? 0, not fired. This is the graph of sigmoid function. Now, the next function, guys, we have is step function. So likewise, you have so many functions, but we don't use all of them. So I'm discussing commonly used functions. So what exactly step function we have is, so I'll first plot the graph. 1 second. I just check the graph here. See, this is how your step function looks like. Okay. Now here you have a condition. Okay. If your x value, okay, if it is more than 0, okay, it means you can write like this. If your x value is less than 0, then not fired. And if your x value is what? Greater than or equal to 0, then will be fired. Okay, you can ignore this condition. It is the same thing I have written in simpler word. This is your x-axis, this is your y-axis. And if I talk about the range of value of y, see, it is from 0 to what? 1. This is the range of value, 0 to 1. This is also called as your step function. Third function you have is tan h. It is also called as tan hyperbolic function. Okay. So I can write the equation for it. Tan h z. Whenever you see a graph of any function, it will have a equation. Simple meaning, guys. Is h. H stands for hyperbolic. Okay. This is e to the power z minus e to the power minus z upon e to the power z plus e to the power minus z. Here it is z, you can write here x, not a problem. It's just a variable name, you can write any variable name. This is the equation of your tan h activation function, and here the range is -1 to +1. Sigmoid and step function have a range from 0 to 1, and here it is -1 to 1. Now if I just plot this function, okay, this is how it looks like. Here it is +1, and definitely this point will be what? -1, and this is 0. X-axis, this is your y-axis. So we can use, it is like optional. We can use tan h in the hidden layer. Okay. And if you talk about your sigmoid function, it is basically used in the output layer. Sigmoid function, because these things are tested on multiple data set and multiple operations. So it was concluded that they are basically used for output function, then they perform better. Sigmoid function is used in the output layer. Now the next function we can write is very important. Okay, so actually there are some problem with these functions. What problems we have? Let's discuss the problems. Actually, previous activation function has some drawback. The drawback is what? Vanishing gradient. This is the problem, guys. These functions are having. What is the meaning of vanishing gradient? So vanishing gradient is a problem when your input is keep on increasing, but your output is not making any change. Okay. When the output stops changing for a given change in x, for a given change in x. Okay, when your output stops changing for a given change in input, let's not say x, input. How can you verify this? For example, if I take sigmoid function, see, if you notice, guys, your x is changing. One second. See, here this is your x-axis, and this is your y-axis. After a certain point, your x is changing. See, it is going till infinite. But your y is not changing. Y is stopped at what? 1. Here also, your x is keep on changing. This will keep on growing, right? Till what? Minus infinite. But your y stops at what? 0. This is a problem called as vanishing gradient. When your input is keep on changing, but your output is not changing. Same for step function. See, your input is changing, but see your y stopped from what? 0 to 1. Guys, are you able to understand what is vanishing gradient? All of you?
Yep.
And if I show you for tan H also, see, after a certain time, this becomes flat and goes till infinite, but your y stopped at 1. Here also it goes till what? In minus infinite, but your y stopped at -1. So this is called as vanishing gradient, when your x is increasing and your output is stopped increasing. Sam, are you able to understand vanishing gradient problem?
Yes.
Okay. Bharat or Sean, Chidyani,
Yes.
you?
Yeah, I got it.
Yep.
Very good. So we need some more activation functions where you can reduce the intensity of vanishing gradient. Yeah, it will be there, but I wanted to reduce the intensity. So we discussed the activation function sigmoid, step, tan H. The fourth one is ReLU. Okay, ReLU activation function. Now, how it looks like. So I'll first give the equation of it. Maximum of 0, x. This is the equation of ReLU function. Now, how it looks like. So for a positive value of 0 to plus infinite of x, whatever value of your x is there, the same value y will possess. Okay, let's say your x is 1, so y will also be what? 1. If your x is 2, then y will also be 2. So for positive value of x, your value of y is also changing. See guys, if you keep on changing your x till infinite, your y will keep on changing. Yes or no? It will not stop. For every change in x, your y will change or not in this case? Tell me.
Yes, y will change. Yeah.
Y will change. But we have a problem in the left hand side. 50% is a problem. For negative value of x, this will be flat. Okay, so if your x is more than 0, so for positive value of x equal to y. But if negative value of x, your y is what? 0. So see, your y is 0. For all negative value of x, your y is 0. So it means I can say here in this part, if I increase x, your y is increase. If I decrease x, your y is decrease. But on the left hand side, I do whatsoever, your y will remain what? 0. So here we have gradient descent problem or not in this side. Guys?
Yep.
Correct? Yeah, we have the problem. Now let's understand this equation better a bit. ReLU of max. What this means? ReLU of max 0, x. So if your x is 5, then your y becomes what? Max of 0, 5. Your y is what? 5, correct? So for positive value of x, your y will be equal to x, right? See the straight line. This one, it is going. But for negative value of x, What is the answer?
0.
0. That's what I'm saying, no? For negative value of x, your y will remain what? 0. It is verified by the equation. Everybody is clear?
Can you explain the mathematics? I'm not very clear on max 0,
Okay.
x.
See,
How
this
does
is the
the
equation.
calculation go?
Yeah. This is the equation. See, this is the equation of ReLU function. Okay. What is the meaning of an equation? You pass the input value, you get the output, right? So your
Yes.
x will be acting as the input. So if I pass any positive input, let's say I'm passing 5. So max 0, 5, because in place of x, what I put? 5. And what is the maximum number between 0 and 5? 5. So your output becomes what? This is giving the output, by the way. Okay. This is giving what? Output. So for a given value of x, your y is 5. Means if your x is positive, your y will be always positive and equal to x. But if you put negative value, that is -5. So 0, x, 0, -5. And maximum value I want, because this is in the equation. Between 0 and -5, which is bigger? 0. Right? So see, for negative value of x, for all negative value of x, your y will remain 0. Make sense?
Yes.
Yes. Very good. And you know what? ReLU has a full form also. Remember this full form. Sometimes it asks in the interview also. The full form is rectified linear unit. Rectified linear unit. This is the full form of your ReLU function. Yes, so we observe we have some sort of vanishing gradient problem still. Okay. So finally, we have one more function called as leaky ReLU. What is leaky ReLU? Here the equation is y equal to maximum of 0.1 times x comma x. This is the equation. Now let's understand this equation a bit better. If your x is 5, maximum of 0.1 times 5, what is the answer? 0.5. So 0.1 multiply 5, and here you have what? 5. It is 0.5, guys. Yes or no? Tell me. Preeti, it is 0.5.
Yes.
Yes.
What is the maximum value?
5.
It is same, right? So if you have a positive value of x, then your y will be exactly same as x, right? Now let's check for negative value. X is -5. So y equal to maximum 0.1 multiplied by -5. And here again -5. Max value of, so minus 0.5 and then -5. What is maximum value?
Minus
Guys,
0,
here what?
0 or 0.5. I think minus 0.5.
Yes. You find something changed with the previous questions.
Yeah.
I think in previous case it was 0, right?
Right.
For every negative value of x, your y was 0 in the ReLU
Yeah.
function. But in this case, at least you will find some slight change, correct? It is not flat, but yes, it will change some bit. Correct?
Yeah, correct.
Sam, are you able to understand in the previous equations if you focus?
Yeah, I
If you are
understand.
giving,
I can see the
yes,
difference.
yes. So guys, in the previous case, if you are passing negative value, your y was 0, it will remain 0. But in this case, at least your y will move by some extent. So you have somewhat sorted the gradient, vanishing gradient problem. So if I just plot the graph of it, see, although in the deep learning questions, you just have to use coding. You just write the name of the function, you will get the answer. But I'm trying to explain you the maths behind it. It may looks a bit complicated, but it will give deeper understanding. Wherever explainability is possible, I'll explain to you. This is your x value, this is your y. For positive part, there is no change, right? For positive part, guys, there was no change. Whatever you have the x value, same y value you get. But what about the negative value? Your value is slightly going to the like this. Okay, it was flat in the beginning, but now it is not flat. It is going like this. So this is the negative value of x for negative value of x. Previously it was flat. Okay, so one conclusion I want to tell you. So these activation functions, guys, are tested by researchers, okay, on heavy data set, and what they have concluded in hidden layer. Okay, I'm just giving one single statement. We have to use which activation function? ReLU. And in the output layer, you can use sigmoid or you can use softmax. So softmax is also one of the activation function. It is very simple. What softmax is? See, in a nutshell, I will explain you what is softmax. See, if you got the value of sigmoid function, let's say 0.7 and 0.6. This is the value of sigmoid. So what softmax function does? It transforms the result like this. 0.6, again 0.7 plus 0.6. If you compute the answer, 0.7 upon 0.7 upon 1.3. It is 0.53 and 0.6 divided by 1.3 and it is 0.46. And if you focus one thing, if you add these two, it will be 1. Yes or no?
Yes.
Okay. So simple idea is softmax gives the answer in the probabilistic mode, but internally it uses sigmoid only. Okay, so in probability format, sigmoid function softmax function trying to give the output. So you have options. You can use sigmoid, you can use softmax, but in the hidden layer, guys, we always will be using what? ReLU function. So I will be giving you this PDF file. Just revise it once, then we will see the coding of it. Okay. I'm just giving a quick drive link. So guys, I have given the notes in the chat box. Please download it. And please revise it. Okay, spend some time on it and revise the concepts. Guys, done with the revision, everyone? Completed? Sudyani, Samson, Priti, Mrigend, Vivek, any question?
No question so far.
Okay. So fine, guys. Now we will see the practical implementation of these
Sir, I have one
activation.
question.
Hmm.
In sigmoid function and step function, the range is same, but
Yes.
the value of fired and not fired is different. Like in sigmoid
Yes.
is 0.5 and step is 0.
You can see the graph is also different in both the cases.
Uh,
See, the
yes,
graph is also
yeah, graph is also different. So is there
right.
any is there any reason, or it
This
just
is
like
how
this?
the graph. This is how this graph was designed. These are very
Oh,
generic graphs. Okay. So some
okay.
graph, if a graph have lot of conditions, then that is not a graph. You know how you have seen in maths also, case 1, case 2, case 3. So we try to minimize the cases. If a graph is having lot of cases, means it is a lot of exceptions we have with the graph. So only generic graphs are considered as the functions.
Okay.
Okay, guys. So let's implement this in Colab. All of you open your Colab file. Although the Python implementation is not required a lot, but how you can code it Python, we will understand. Here math library is required. Import math. So what was the formula of sigmoid function? Y equals to 1 upon 1 plus e to the power minus x, right? I know what e is nothing but 2.71. Okay, it is the epsilon value. You can print also. See, print math.exp exponent of 1. See, 2.71. So exp1 is nothing but e. Okay, exp1 is nothing but e. So I will just encode this formula in the base raw Python. We are not implementing data science. It is just raw Python coding. I'll just define one function, sigmoid. It will take the value of x, right? Now write the equation. Print 1 upon 1 divide by bracket 1 plus e to the power minus x, right? So math dot exp and then what? Minus x. 1 upon 1 plus, and this is nothing but e to the power minus x. Run it. Now you can call the function sigmoid of 7, 0.99, sigmoid of 100, see 1. Likewise, you can compute the sigmoid function. Do it, everyone. Do it, all of you. Sigmoid function, implement it.
Sir, you print math.exp1. We can take any other value as well.
No. I wanted to check the value of E. exp1 is nothing but E value, epsilon. Okay.
Okay.
Euler constant. Done, everyone? It's working. Formula.
Yes.
Yes.
Okay. Now we'll write other formulas. Let's have a quick break. After that, I'll show you other formulas also. And then we start with the loss functions. Okay, guys, you all are back, everyone.
Yep.
Now I can show you the tan h function also. So we don't have direct function for that. Okay, I'm just showing you the raw Python coding. Tan h x function. The equation was here y equal to e to the power. See here, e to the power x minus e to the power minus x. Upon e to the power x plus e to the power minus x. So how can you write it? Def tan h x. Okay, then you can say print math.exp x math.exp minus x, then divide by divide math.exp x plus math.exp minus x. Tan h 5 tan h minus 500. It is infinite. So guys, one more thing. I told you that these functions, okay, have a range from -1 to +1. Okay, but sometimes they misbehave because we are not using their direct function. Okay, rather we are using what? We are using the raw Python code. So if they are going out of boundary also, then don't worry in that case. This is just a raw Python implementation because we will use the direct functions name. This is for tan h. Then you want to write can value here. X max of 0 comma x. This is for ReLU. So def ReLU function x and then print max of 0 comma x. So whenever you call this function ReLU, let's say 6, ReLU minus 6, it will be 0. See, try these two functions, check.
Govid, Govid,
Yes, you are
can you
saying
hear me?
something.
Yes, I think there's a little issue with your expression. Your denominator when you're doing your tan H, the tan X, there should be there should be I put a parenthesis in on the denominator to show that they are all together. Because when I'm running
Okay,
mine right
here.
now,
Okay.
yes,
Wait. Here, right?
yes, sir. There should be just like the way you did for the numerator. So because it's going to give you a different value.
Okay, 1 second. So in that case, let me just fix the brackets. So now this is for this bracket.
Mhm.
Yes. But yes, sometimes whatever expressions we are writing, okay, it may gives out of the bound range result. Okay, this is very obvious because they are Python. So guys, can you try for leaky ReLU by yourself? Everyone, can you try for leaky ReLU? And paste the answer in chat box.
No, would you mind? I mean, I cannot do that. Would you mind teaching us?
Sorry, Miguel, come again.
Can you tell me how?
Okay, you know the formula of leaky ReLU? Tell me the formula of leaky ReLU first.
Just show in your collab.
No. It is the formula of ReLU function. I'm asking like leaky ReLU function. The formula. I gave the PDF file also. Check that PDF file.
I mean, why can't you show in collab?
I'm showing you. I'll just wait for 1 minute, others to trying. Okay, others are
Okay.
trying it.
Thank
Okay,
you.
I'll just tell you. Okay, guys, let me explain you for leaky ReLU code. Anyone have completed
Yes,
the
I've
leaky ReLU
completed
one?
it. Yeah.
So what functions have you written?
Defined the leaky value with X and
8 is maximum of, print maximum of
0.1 times
0.11
X,
times x, right? And then
comma X.
again x. Do it, guys. Complete it, everyone. Done? Okay. Now, guys, we'll learn about loss functions. Okay. So likewise, we can implement all the activation functions with the raw Python coding, because when we implement ANN, CNN, that time we don't go for their maths part, rather we just write a single statement and it worked automatically. Okay. Now we will see the loss functions. Guys, what is loss function, by the way? Anyone wants to explain what is loss function? Deepti, Bharat, what is loss function? Vivek?
It will it will show the difference between the predicted output and the target output.
Correct. So loss function is a mathematical function that measures the difference between the predicted output and the actual output, right? Of the model. Actual and predicted predicted and actual output of the model. This is what the definition of loss function, or you can write our goal is to reduce the loss and increase the accuracy of any model, any machine learning or deep learning models. So we have various kind of loss functions, guys. You have mean absolute error, mean square error, okay, log loss. So generally for regression type of problem, we use root mean square error, okay, or mean square error. And for classification type of problem, we use log loss or binary cross entropy. This is called as same thing. So I'll just write the formula for loss function, and then we will practically implement that also. The first loss function we will discuss is mean square error. MSE, right? What is MSE? 1 upon n, that is mean square error, summation of I from 1 to n. Yi means y actual minus ypp means y predicted square. Okay, this is called as mean square error. You have seen this formula already in the machine learning classes. Now, if you talk about root mean square error, so it's called as RMSE. Okay, so RMSE is nothing but under root of MSE, or you can write under root of summation. Here you have 1 upon n. Yi means y actual minus y predicted. Understood, guys? This much. These two formulas, you know it already, right? Bharat, tell me, Samson, are you able to understand these formulas?
Yes.
They are already being used in the machine learning classes. The next one we have, third formula is MAE, stands for mean absolute error. Okay. So that time it was MSE, mean square error. You take the square, but this time we will not take the square. We will take the absolute value. What is the meaning of absolute value? So if you pass any negative value in the absolute value, it becomes what? Positive. And if you pass positive value, it will remain positive. So no matter whatever value you pass inside this pipe boxes, it will return a positive value. So mean absolute error 1 upon n summation I from 1 to n. yi yp. That time it was square like this, but it is not square anymore because this is a mean absolute error. Okay, we will take the absolute value. The next one we have is log loss. It is also called as binary cross entropy. Binary cross entropy. So it is nothing but 1 upon n. Listen, this is important, guys. 1 upon n summation I from 0 to n. yi means y actual. Log of y predicted. Okay, log of y predicted plus 1 upon 1 minus, okay, 1 minus y actual dot means multiply log 1 upon y predicted. This is the formula of your log loss.
Sir, in the interview, do they ask these kind of
No.
formula?
No,
No?
no, no, no.
Okay.
I'm just trying to go a bit deeper in maths. Therefore, but if you know these concepts, if you don't remember the formula, that is fine. But if you know, like for behind every function there is a formula associated, then you confidently able to answer, right? You can't
Okay.
explain the formula, but you actually can explain there was a formula behind the scene. Okay.
Okay.
Please use this, revise this formula quickly. I'm just giving the file again. Then we practically implement it. Please download the notes, guys. I updated the notes. Re-download it. yi means y actual data. Okay. And yp means y predicted. And by Srimi Vision, all of you revised?
Yes, done.
Okay. So I have one hands-on. 1 second, I'll just show you. Okay. So I have an odd hands-on with me. So I'll explain you. So I use NumPy library. Okay. I have two data values, two arrays actually. One is the y actual array. Okay. And this is your y predicted. Two array I'm having, guys. Run it. Why I'm not creating list? Because if you create list, in list you cannot perform the mathematical operations. Okay, which is why we are taking the array. This is your y actual and this is your y predicted. Okay, I have to can take any value, not a problem, but I have intentionally take 1100 view because that will be used in the log loss also. You will understand there. So I don't think like we have taken just five values, five actual value and five predicted value, and their difference will be the loss. First one is mean square error, right? So if I write the formula for mean square error, if I write here, you will understand it. So it is nothing but 1 upon n y actual minus y predicted, right? This was the equation of MSE. So I created function. Function name is MSE. Listen carefully, guys. Now, here I will pass two things, y actual and y predicted. Because if you pass these two values, because based upon that only your calculations will happen. And here I have taken one variable as total error as 0. You know what? You cannot compute this formula directly. You have to go step by step. So what is happening here? You are taking y actual, then you are taking what? Y predicted. You are taking y actual, and then you are taking y predicted, and taking the square and taking the difference of both of them, and then making the square. And this is for one point. You can have hundreds of data points. In this case, 5 data points I am having. So 5 times y actual minus y predicted square, y actual minus y predicted square will perform, and then it will be added. Summation means what? They will be added. So that result is called as what? Total error. Mean I will compute later. So if you remove the mean, then it is what? Total error. So this will happen for loop. It will be applied and happen multiple times. Therefore, I will be considering a value of total error as 0. So what is GIF function? In the for loop, you can iterate only on one list or one array for I in range, for I in list 1. But using the GIF function, at the same time, you can use two for loop here. This y actual will go into y actual variable and y predicted will go into y predicted. What it does? So one by one value it will take from y actual and yp will take one by one value from y predicted. And what it does? First, listen, not don't look at here. Let's say it has taken y actual and y predicted. So first they will perform a subtraction, right? y actual minus y predicted, then make the square, right? See, here you have 2. Square means what? Exponential star 2. And this is for first value. First y actual and first y predicted was taken, and you have subtracted and made the square. You got some value. And before the first value, what was the answer of total error? 0. Okay. So if you add 0 with the first result, the answer will be first result. Then y actual and total result you have stored in total error. Now in the first iteration, total error value is changed from 0 to the first result. Next time, y actual and y predicted will take second value from this list. Okay. They will again perform y actual minus y predicted, does the squaring, and it will add to the previous value of total error, because ultimately here you have a summation of after all the computations, all the value get added. So one by one, so total error contains the result of first value. It will get added to a second value, and total result get stored in the again total error variable. Now it will take the third value, fourth value, fifth value, and hundreds of value. And finally, you will get the result in total error. Now, once you have that total error, you want to compute the mean also, right? See, 1 upon n, then only the formula gets completed. So you see, total error divided by length of y actual. How much the length was there? 5. You can take the length of y actual also, you can take the length of y predicted also. So when you divide by total number of value, it will return the MSE. See, total error was 1.58 and mean square error is 0.366. Are you able to understand this thing? How this loop worked? Here, GIF function is very important because simultaneously one value from y actual and one value from y predicted need to be taken out and perform the computation, and result will be stored in total error. Again, this one value it will take, perform the computation, and finally your total error will have the squared value, and then you take the mean and your formula gets completed. Sam, are you able to understand how it worked?
I was a little bit away, but I would look at. I mean, I watch what you said before now, but I understand what you just said.
Perfect. But when you write these formulas by yourself and by seeing this actual notation, then you guys will understand. Bharat, Deepti,
Yeah.
Preeti, you?
Sir, for calculating this MSC, we are dividing with the lane of the actual y actual. We can also divide with the that predicted y
Yes,
predicted and the length.
both have the same
Yes.
value. Yes, both have the same value. Yes.
Okay. Yeah. Okay. Otherwise, I got
Right,
it.
this is for mean square error, but if you go for uh, mean MAE, mean absolute error, it is nothing but 1 upon n. It has an absolute value, right? Y actual minus y predicted. You don't have squaring over there. See, I wrote the value. Mean absolute error. Same thing. It will go GIF function. Now, absolute of y actual minus y predicted. Just a quick change. Absolute of y actual minus y predicted, and result will be stored in total error, and finally it will make a mean 1 upon n, right? Okay. And how this log loss is working, I will not explain it right now because this will be your home task to understand how log loss works. Okay, therefore try to create the formula by yourself for log loss. Okay, this one, use some maths concepts, research on internet, and then I will explain that to you. So nobody will ask you to derive these equations, but you should know what actually goes behind the scene. Okay, and if you talk about root mean square error, it is nothing but the square root of mean square error, right? RMSE, root mean square error. What exactly it is? import math. RMSE is nothing but math dot sqrt of let's say I'll store the result here. Okay, this is the root mean square error. Okay. Oops. Did I made any mistake? If I put here, let's say 4, it is 2. Okay, that should be a number because it is taking a object of function. Okay, I can directly pass the value here 0.366 because it is storing the output of the function. Okay, that may not be real number. Okay, this is how you can pass the mean square error to compute the RMSE. Okay, math.sqrt formula is that time because there is no direct function for RMSE. You can compute like this. So I will share guys this Colab file with you. You can try these questions and practice it by seeing the PDF file, the formula I have given. Okay. And in tomorrow class, we will be starting with the next deep learning neural network, that is convolutional CNN part. So what was the agenda for today's class? Just to understand what is activation function, how many types we have, what is loss function, and what type we have, and their practical implementation using the raw Python coding. Sam, are you able to understand everything what we learned today?
It's pure mathematics. I did.
Yes.
I was following, but this is pure mathematics.
Yes, it was pure, but from tomorrow onwards, we will not go for pure mathematics because again,
Okay.
in the very maths is required for data science. Of course, this is truth, correct? So at least
Mhm.
this much maths is. That's what I'm explaining line by line. This course.
Yeah.
So some sort of maths is required. Of course, nobody can escape out of it, right?
Mhm.
So thank you guys for the class and joining the session. We will be connecting tomorrow the same time. Okay. See ya. Take care.
All right. Thank you. Bye-bye.